champion, welcome to Bhanzu classes and hope you are excited for this video lesson. Yes, so let's quickly dive into this exciting topic, but before I tell you the topic, let me quickly ask you a question to think of. And the question for you is, look at this picture and tell me what amount of water is filled in these bottles. How will you tell me? The capacity of each bottle is 1000 ml. We can see that these bottles are neither filled entirely nor these bottles are empty. So we need to tell that what part of it is filled. So let's talk about the first bottle. Okay, let's say this is filled 100 ml out of 1000 and this is 700 ml out of 1000. Now if I ask you what is the total amount of water in these bottles, how will you tell me? What do you need to know for this? So that is what we are going to learn today, and we are going to talk about operations on rational numbers, and after that we will be moving on to closure property also. Is that clear? Are you ready to learn? So let's quickly see. Okay, so now first of all I really want to check, do you remember what rational numbers are? Okay, then let's quickly check it. First of all, we can see the natural numbers, right? The natural existing quantities starting from 1. If we add 0 to it, it will become a new set of whole numbers. If we add the negative numbers to it, it will become the set of integers. If we add the fractions to it, we will get a new set. If we add the negative fraction also, then we will get the complete set of rational numbers. So that means natural numbers, whole numbers, integers, fraction, negative fraction, everything is a part of rational numbers. Is that clear? Do you remember now? You learnt it in the previous grade, and this can also be written in the form of P over Q, where Q should not be 0. Okay? Now, let's quickly get a mastery over this concept, and we are going to study about 4 operations. Okay, so what are these operations? Let's see. Addition, subtraction, multiplication and division. Okay, and closure property is the next thing. Okay, let's quickly talk about the addition of rational numbers. Let's see. The question for you is minus 7 over 5 plus minus 2 over 3. How will you solve it? Let's quickly check. First of all, what do we want in the denominator? We want the LCM of 5 and 3, which is 15. So let's quickly make it. This is going to be minus 21 over 15 because I am multiplying the numerator and denominator by 3. Okay, and then what about the next fraction? Here I need to multiply the numerator and denominator by 5, right? So what will it be? It is going to be minus 10 over 15. And then what is the next step? You will keep 15 in the denominator and then minus 21 minus 10, which is equals to minus 31 over 15. So did we get the rational number only? Yes, and we also learned how can we perform the addition operation on rational numbers. So let's quickly go to the next slide and let's quickly see the subtraction of rational numbers. So here you can see A over B minus C over D is equals to A over B plus additive inverse of C over D. So now do you remember what is additive inverse? Additive inverse is what you add to the number to make the sum 0. Okay, let's say the question is this. Okay, now what is the other form of writing it? You can write it like this also. And now this is just like the first question that you did on the previous slide. Can we quickly solve it? What is the LCM of 7 and 8? 56. Okay, we want the denominator to be 56. So first of all, we will multiply the first fraction. Okay, numerator and denominator has to be multiplied by 8. So this is going to be 40 over 56. And what about the second fraction? You need to multiply the numerator and denominator by 7. So this is going to be 21 over 56 and then 56 at the bottom and then 40 minus 21, which is equals to 19 over 56. Isn't it easy? Yeah. Now and we will see the next operation, that is multiplication. So the question is given here. Now what do we need to do? We need to multiply the numerator by numerator and denominator by denominator. Easy. So minus 7 multiplied by minus 2 is what? 14. And then 5 multiplied by 3 is what? 15. And we are done. Multiplication is really easy, isn't it? Now let's quickly check the division of rational numbers. And you can see A over B divided by C over D. How can we solve it? First of all, you are going to take the inverse of division, that is multiplication. And then you will find the reciprocal of the fraction C over D, which is D over C. Okay, so now let's see the question. The question is here. How to solve this question? For this question, let me do the same thing. Okay, I will be multiplying and then I will be finding the reciprocal of minus 2 over 3. Okay, now what next? This is equals to 21 over 10. Isn't it easy again? Yeah. So this is how we can perform all the operations on rational numbers. Okay. So now we are going to look at the first question that we started. Okay. What was it? So this is filled, let's say 700 ml out of 1000 ml, and this one is 100 ml out of 1000 ml. So what is it going to be? Again easy. We can see the denominator is same. We don't even have to change it. So what is going to be the answer? The answer is going to be 800 over 1000. Yes, clear? This much of the water is filled in these two bottles. So till now you have learned how can we perform the operations on rational numbers. So I want you to practice few questions because that is very important. Okay, so you can see few questions. Let's quickly check. Now LCM of 15 and 3 is 15 only. So no change in the first fraction. In the second fraction we will multiply the top and bottom by 5. So this is going to be minus 50 over 15. And then 15 at the bottom. Minus 8 minus 50. This is going to be minus 58 over 15. Yeah, clear? Now let's do the second question. LCM of 7 and 4 is 28. Okay, so let's multiply the numerator and denominator by 4. In the first fraction, you will multiply by 4. Okay, so we are going to get 32 over 28. And what about the next one? You are going to multiply the numerator and denominator by 7 here. So this is going to be 35 over 28, right? And you could have written the additive inverse also if you remember. Now we will be writing 28 in the denominator, 32 minus 35, which is equals to minus 3 over 28. Okay, clear? So now we will see the multiplication question. So here you can see that we can do some cancellations and we can make the calculation easy, isn't it? 4 times 1 is 4, 4 times 4 is 16, 3 times 1 is 3, 3 times 3 is 9. So we are left with minus 1 over 4 multiplied by minus 1 over 3. So this is 1 over 12. Yeah, easy. Now let's do the division question. 12 over 7. This will be changed to multiplication, then minus 49 over 48. And what to do next? 12 times 1 is 12, 12 times 4 is 48, 7 times 1 is 7, 7 times 7 is 49. Then what? 1 over 1 multiplied by minus 7 over 4. So what is the answer over here? That is going to be minus 7 over 4. With this, we have revised all of it that we have learned so far. So let's quickly go to the next part of it. And that is nothing but the closure property. So now do you remember what is closure property? Closure property means if you perform an operation on certain element of a set, then the result of the operation will belong to that set only. Okay, so now let's see. Okay, so we have these many properties: closure property, commutative property, associative property, distributive property, that we will be learning in the next classes. But first of all, we are going to talk about only closure property. Now if we see the closure property in case of whole numbers, okay, what do you think? If you add two whole numbers, are you going to get whole numbers only? Let's quickly check. What is 3 plus 4? 7. That is whole numbers. So yes. What about subtraction? If you subtract two whole numbers, will you be getting the whole numbers only? What about, let's say, 4 minus 7? That is minus 3. This is not a whole number. So we do not get always whole numbers. So the answer is no. So What about multiplication? 4 into 3 is 12. That is again a whole number. So yes, whole numbers are closed under multiplication. And if I talk about division, what do you think? If you divide two whole numbers, do you always get whole number only? What about the case, let's say 5 over 10? This is equals to 0.5, which is not a whole number. So whole numbers are not closed under division. So let's quickly check with the integers. Okay, let's say minus 2 plus minus 4. What is the answer? Minus 6, which is an integer only, so they are closed. Okay, let's check about subtraction. Now let's say minus 5 minus minus 4. This is going to be minus 1. This is again an integer, so integers are closed under subtraction. What about multiplication? Minus 3 multiplied by minus 4 is what? 12. So here you can say that integers are closed under multiplication. But in case of division, if you divide minus 5 over minus 10, then this is going to be what? This is going to be 0.5, which is not an integer. So integers are not closed under division. Is that clear? So we have revised the closure property for whole numbers and integers. Now we will go ahead and we will quickly talk about the closure property for rational numbers also. So let's get a mastery over it and we can see the closure property of rational numbers. Okay, so let's quickly do it. Now let's say if a question is 1 over 6 plus 2 over 6. Okay, this is 3 over 6. Yes, so we are getting the rational numbers, so true. Okay, so we can say that rational numbers are closed under addition. Now what if a question is, let's say 2 over 6 minus 1 over 6. This is going to be 1 over 6. So we can say that rational numbers are closed under subtraction also. Okay, we will put a tick mark over it and you can write yes also. Okay, now what about multiplication? Are the rational numbers closed under multiplication? Let's quickly check. Okay, what is 1 over 2 multiplied by 3 over 4? Okay, this is going to be 3 over 8. Oh yes, we are getting rational numbers. And what if it is 1 over 2 multiplied by 0? That is also rational number because you can write it as 0 over 1, right? So we can say that rational numbers are closed under multiplication and division. Let's quickly check it. Let's say the question is 1 over 2 divided by 3 over 4. How to solve it? 1 over 2 into 4 over 3. 2 times 1 is 2, 2 times 2 is 4. So answer is 2 over 3. We get a rational number. Okay, this is perfect. What if a question is, let's say 3 divided by 0? What is going to be the answer? The answer is undefined. I am not getting rational number over here. What if it is 0 divided by 3? Then it is 0. Then no problem. But in this case, if you see, the answer is undefined. So I can say that rational numbers are not closed under division. No. Okay, so let's quickly practice. Okay, we are going to verify this closure property for addition and multiplication once again. Okay, so now let's say the numbers are minus 5 over 7 plus 8 over 9. First of all, we will do it for addition. Let's quickly check if we get the rational number only. Now the LCM of 7 and 9 is 63. Okay, so I am going to multiply the first fraction by 9. Okay, numerator also and denominator also by 9. So let's quickly get it, and this is going to be minus 45 over 63. And what about the next one? 56 over 63. And this is going to be what? I am going to write 63 in the denominator and then minus 45 plus 56, which is going to be 11 over 63. Isn't it easy again? Yes, and we have seen that we get the rational number. Now quickly check the multiplication. Okay, now minus 5 over 7 multiplied by 8 over 9. So 8 into 5 is 40 minus 40 over 63, which is again a rational number. So now we will quickly summarize what we have learned. So what we have learned is, first of all, we learned how can we perform addition, subtraction, multiplication and division on rational number. Then we talked about the closure property. In closure property, what we talked about is, we talked about addition, subtraction, multiplication and division. We checked are rational numbers closed under these operations or not, and we checked these are closed under addition, subtraction and multiplication, but not under division. Is that clear? Okay, so now stay excited to learn the next properties also. We still have lot more to discover, just like I told you in the previous slide. So here I would like to say thank you for joining me in this exploration of rational numbers. Stay curious, keep learning. I will see you in the next video. Bye-bye.